of simple events. Today we're going to be talking about the theoretical probability of compound events. Remember that a compound event consists of two or more simple events. And to find the probability of a compound event, you write the ratio of the number of ways the event can occur to the total number of equally likely possible outcomes. So in this example, it says that Jacob rolls 2 fair number cubes. Okay, so we have 2 fair number cubes, and they want us to find the probability that the sum of the numbers he rolls is 8. So the probability that the sum is going to be 8. Well, remember the sum means we're adding. So in step 1, we're going to use the table to find the sample space for rolling a particular sum on 2 number cubes. Each cell is the sum of the first number in that row and column. So we're just going to add these two. If I rolled 2 ones, my sum would be 2, and then 3, 4, 5, 6, and 7. If I rolled a 2 and a 1 and I added them up, it would be 3, then that would be a 4, 5, 6, 7, 8. If I added a 3 and a 1, it would be 4, 5, 6, 7, 8, 9. If I added a 4 and a 1, that would be 5, 6, 7, 8, 9, and 10. If I rolled a 5 and a 1, the sum would be 6, 7, 8, 9, 10, 11. If I rolled a 6 and a 1, my sum would be 7, then 8, 9, 10, 11, and 12. So step 2 is asking me how many possible outcomes are in the sample space. Well, if I have a 6 by 6, that would be 36 possible outcomes. They want us to circle the outcomes that give a sum of 8. You can see they happen diagonally. So I want you guys to circle the 8s that appear in our number chart. Okay, and it's asking how many ways are there to roll a sum of 8. Well, I have 1, 2, 3, 4, 5. 5 ways to roll a sum of 8. So what's the probability of rolling a sum of 8? Would be 5 out of 36. And that cannot be simplified. In the next section, it talks about finding probability using a tree diagram. You can use a tree diagram to calculate theoretical probability of compound events. So in this example, it says a deli prepares sandwich with 1 type of bread, and our choices are white or wheat, and 1 type of meat, so you get your choice of ham, turkey, or chicken, and 1 type of cheese, and you have a choice of cheddar or Swiss. Each combination is equally likely, and it's asking us to find the probability of choosing a sandwich at random and getting turkey and Swiss on wheat bread. Okay, so the probability that we would end up getting turkey and Swiss on wheat. Since they want us to make a tree diagram, we are talking about breads, meats, and cheeses. Okay, so we're actually going to draw a little tree diagram. For the bread, I'm going to go ahead and write out the word white and wheat because they both start with WH. But for the meats, you can go ahead and abbreviate. You don't have to write out the whole word. So we have a choice of ham, I'm going to put an H, turkey, I'm going to use a T, and chicken, I'll use a C. On the wheat bread, I also have a choice of ham, turkey, or chicken. For the cheeses, we have a choice of a slice of cheddar, I'm going to use CH, or Swiss, I'm going to use SW. Here, same thing, CH, SW. For the chicken, same thing, CH for cheddar and SW for Swiss. For the wheat, running out of space, cheddar, Swiss for the turkey, we have cheddar or Swiss, and for the chicken, we have cheddar or Swiss. So it says to find the number of possible outcomes. So that would be counting all the outer branches. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. And the probability of getting turkey and Swiss on wheat bread, well, we have wheat turkey on Swiss bread turkey with Swiss cheese on wheat bread is only going to happen 1 out of 12. So that would be your probability. Okay, on the your turn, you're going to pause your video and you're going to use this diagram to answer these 2 questions. Okay, on number 3, it's asking you to find the probability of a ham sandwich. Well, notice that you could have ham with cheddar or ham with Swiss, or you could have ham with Swiss and cheddar on wheat. So that would be 1, 2, 3, 4 out of a total of 12, but we can simplify that. Divide by 4, that would be 1/3. That's what you should have gotten for that one. Counting all your ham sandwiches, which is 2 on wheat and 2 on white and 2 on wheat. On number 4, it was asking you to find the probability of a sandwich containing Swiss cheese. Well, that's going to happen 1, 2, 3, 4, 5, 6 times. And again, it's out of 12. And of course, that would simplify to 1/2. That's what you should have gotten on that one. All right, on the back, you are finding probability using a list. So one way to provide security for a locker or personal account is to assign an access code number known only to the owner. The combination for Keem's locker is 3-digit code that uses the numbers 1, 2, and 3. Okay, so it's 3-digit code, and it uses the numbers 1, 2, and 3. Any of these numbers can be repeated. Okay, so find the probability that Keem's code is going to be 222. So they walk us through as they tell us in step 1, list all the codes that start with 1 and have 1 as the second digit. So they listed all the possibilities with 1 as the first and the second digit. Then they used all the codes that start with 1 and have 2 as a second digit. And then they started with 1 that have 3 with a second digit. And then they repeated that same process, but for starting with 2. And you can see that then they did it with the 3. So the next step, they ask us to find the number of outcomes in the sample space by counting. Well, if we count our tables, 1, 2, 3, 4, 5, 6, 7, 8, 9, and each table has 3 possibilities, well, we see that 9 times 3 would equal 27 outcomes. 27 possible outcomes. Another way to look at that is, since we have a 3-digit code, there are 3 numbers that could go in the first position, 3 numbers that can go in the second position, and 3 numbers that can go in the third position. Well, 3 times 3 is 9, and 9 times another 3 is also 27 possible outcomes. Okay, so the probability that his code would be 222, you could see that that only happens once in all of our possibilities. So 1 out of 27 total. So our probability that his code is 222 is 1 out of 27. on the your turn, you're doing something very similar. So I want you to go ahead and pause your video and read number 5 and try to come up with your answer. Okay, it says Martha types a 4-digit code into a keypad to unlock her car doors, and the code uses the numbers 1 and 0. So if the digits are selected at random, what's the probability of getting a code with exactly 2 zeros? You should have started a lot like the example you saw above, starting with, we'll go ahead and start with how many ways the 1 will appear in the first and second position. So we could have 1, 1, 1, 1. We could have 1, 1, 1, 0. We could have 1, 1, 0, 0. We could have 1, 1, 0, 1. We could have 1, 0, 1, 0. We could have 1, 0, 0, 1. We could have 1, 0, 1, 1. And we could also have 1, 0, 0, 0. So we're going to do the exact same thing, but this time we're starting with the 0. So we could have 0, 0, 0, 0. We could have 0, 0, 0, 1. We could have 0, 0, 1, 1. We could have 0, 0, 1, 0. We could have 0, 1, 0, 1. We could have 0, 1, 1, 0. We could have 0, 1, 0, 0. And we can have 0, 1, 1, 1. So first of all, you need the total possibilities. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 possible outcomes. And they want us to find how many have exactly 2 zeros. So I'm going to box those. We have 1, 2, 3. We have 4, 5, and 6. So the probability of getting 2 zeros would be 6 out of 16, but we could divide by 2, which would give us 3 out of 8. That should have been your probability. Okay, if you have any questions, we will talk more about this. Be sure to write them down. See you tomorrow.